one is functions of several variable. Unit 2 is differentiation. Unit 3 is application. Okay, that will be application of differentiation. Okay, so let us start. So we are going to start with the function of several variable. In function of several variable, we had seen what is Euclidean space, correct? So Rn is called Euclidean space. Why this is called Euclidean space? Because it satisfies all the postulate axioms of Euclidean geometry. That's why it is called Euclidean space. Okay, and if you want to write this as Rn will be x1, x2 up to xn, where each xi belongs to R. Okay, for all I from 1 to n. So if I represent R2, that will be your plane, correct? So this is how we write, and we know two things. We can add any two Rn. If I take x and y, which is in Rn, then we know how to add them. We know how to scalar multiply, correct? These two things we are aware with. So and later on we'll define, actually the main motto was to define norm in this Rn, because if you cannot find distance between 2 points, then how will you able to define the definition of continuity, differentiability? These things we cannot define that. So we require the distance between 2 points. So for that we'll first go to inner product space. Do you remember the definition of inner product space? Let V be a real vectors. I think this is also done in your algebra part. A function V cross V to R is called as an inner product if it satisfy the following property. Anybody? What are the properties? If you remember, the first one is it should be positive, and inner product if it is 0, if and only if that x is 0, then only, correct? What next? Inner product of xy, that is same as inner product of yx, correct? What next? Alpha x comma y, that is equal to alpha inner product of x comma y, where alpha is your real number. For complex number it is something else, it will be alpha. If it is alpha here, then it will come as alpha. If alpha is here, then it will come as alpha bar. But in real cases there is no issue of that. And the last one is x plus y plus z, that is equal to xz plus yz, correct? So these are the four properties. And a vector space V together with inner product space, that is together with an inner product defined in it is called inner product space. Okay, so finally we have defined inner product space, but as I told you, our main motto is to define distance between them. So before that, let us define dot product. So dot product in, so dot product in Rn, how is that defined? If x is x1, yn, then x dot y. What is x dot y? Anybody? Correct. So dot product is a function from Rn to R, and the value will be x1 y1 plus x2 y2 plus xn yn. Yes. So the question was, is dot product an inner product space? And we have proved it, I think, correct? I'll just write exercise. Prove that inner product of x comma y, that is defined as x dot y. Prove this is an inner product. This is an inner product in Rn. And quickly you can check all the properties. It will satisfy since it is dot product, and I have already told you. Yes, we have proved it if you remember. I'm not going to that part. So finally, what do we say? Rn together with dot product, or I'll write inner product space, inner product which is dot product is called Euclidean inner, is called Euclidean inner product space. Okay. What was the next thing? To define norm of a vector. Norm of a vector in Rn. Anybody? How does we define norm? If x is equal to x1, x2, xn, which is in Rn, how do we define norm x? Norm x is equal to square root of, yes, perfect, root, yeah, inner product, that is same as dot product in our case. So that means root of, it is x1, it should be x1 square, na? X1 square plus x2 square and up to xn square. Yes, so if you take some example, then now we try to see this guy satisfy all the property which we were using for mod was satisfying all the property. This guy also satisfy all the property, correct? Actually this is in, if you take it is in R, then it is your mod. If you take x as real number, then this will be root of x1 square, and that is mod x, if you remember, correct? So this is same as mod. So our condition was to check whether it satisfy all the properties. That means let me write the properties, and I think we have proved that this guy satisfy that. This guy fits, we can replace, uh, this for the at the place of mod in Rn. Properties of norm. So you are having x and y in Rn. You should write x equal to x1, x2 up to xn, y equal to n, like that, and alpha be a real number. Then first property is norm of x, that is same as norm of minus x, correct? And that is quite simple to prove. The second one is norm of alpha x, that is equal to mod alpha norm x. Third one is norm x is always positive. Fourth one is norm x is 0 if and only if your x is 0. 0 in Rn की बात कर रहा हूँ मैं, so that means each coordinate must be 0. And the fifth one was your triangle inequality, that is that this is less than equal to norm x plus norm y. Correct? For this we were using actually Cauchy-Schwarz inequality. Do you remember what is Cauchy-Schwarz inequality? क्या था बोलो? If you write in terms of dot product directly, that is norm x dot y mod of x dot y, that is less than equal to norm x norm y. Correct. And this is what we proved in your SyBsc by using the values. यहाँ पे हम लोगों ने क्या लिखा था, x1 y1 x2 y2 that is less than equal to ऐसा. We are doing that. But यहाँ पे we have the notation now, that is this left hand side is your x dot y and right hand side is norm x norm y. So by using this you can quickly prove this. How will you start? How will you prove this? Anybody? How will you start? The fifth one. I'll just prove the fifth one because others are quite easy. Proof of fifth one. Anybody? How will you start? You want to prove norm of x plus y, it is less than equal to something. That was quite simple to prove, correct? You start with this. You start with norm of x plus y the whole square. What will this be? This will be x1 plus y1 the whole square plus x2 plus y2 the whole square plus dot 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 xn plus yn the whole square, correct? Do you agree? And if you solve this thing, you'll get this is same as norm x the whole square plus norm y the whole square plus 2 times x dot y, correct? Yes, do you agree? If you solve this thing, take first term, take last term, and if you take middle one, then it will be 2 into x dot y. And if you then this guy is less than equal to norm x the whole square plus norm y the whole square plus 2 times mod of x dot y. And can I use now Cauchy-Schwarz inequality? So at the place of this I will be writing this is less than norm x the whole square plus norm y the whole square plus 2 norm x norm y, and this thing is less than equal to norm x plus norm y the whole square. What was my left hand side? This. So if you take positive square root, then you will be having norm of x plus y, that is less than norm x plus norm y. Correct? And it's proved. Yes. Correct. Now how do we define distance between 2 points? Distance between 2 points in Rn. So if you are having x and y, that is x1 up to xn, y1 up to yn. So how does the distance? Distance is defined as norm of x minus y, correct? Which is same as square root of x, correct? Very nice. Up to xn minus y in the whole square. Yes, and if you remember, अगर n इक्वल टू 2 हो तो ये अपना डिस्टेंस फॉर्मूला बन जाता है जो हम लोग पहले यूज़ करते थे. So I may also denote this as distance of xy, d of x comma y, which is same as norm of x minus y. And if I write in general, then I can write it as summation, and summation I is equal to 1 to n xi minus yi the whole raised to 2. You can write yi minus xi, there is no issue in that, correct? So once you are having distance between 2 points, can you define open ball in Rn? Open ball in Rn, correct? Let us just before going to Rn, let us see in R2 if you are having a open ball, correct? So what is the equation for this? If it is in R2, then what is equation for this? For a circle, equation of a circle. Yeah, if I take in general, then it will be something like this. Your center is even A2 if I take, and the radius is R. So can you tell me the equation of this circle? And open ball means what? I want interior points. I want all the interior points. That means I'll define a set that is BAR, that is equal to, where A is your A1, A2. Here is your A. Okay. So this is equal to x comma y in R2. What is the condition this should satisfy? That means all the points should be lie in the circle. So what is the equation of circle? If you remember, yes. If you are having center and radius, can you tell me? X minus a1 the whole square plus a2 the whole. Yeah, this is the equation of circle. Now my question was to give me the interior points of this, correct? So that should be less than. Very nice. So that will be x minus e1 the whole square plus y minus e2 the whole square, that should be less than r square. If you take square root, then this guy is same as norm of x minus a. Do you agree? Because norm को हमने define ही ऐसे किया, square root of this, correct? So this was for two variable. In general, you can do that, correct? If you want to define open ball, then this will be this. If the question was closed ball, then if you wanted to, yeah, then closed ball, then yeah, correct. So this will be less than equal to. Okay, is that clear to you, everyone? So in general, I can write x belongs to Rn. This is norm of x minus e, that is less than r. That gives me an open ball. This is the definition of open ball, correct? Yeah. So open ball in R. What is open ball in R? Tell me. Open ball in R. What is open ball in R? That means this norm will be replaced by mod. And if you solve that mod, that means what? X is lying between E minus R and E plus R. Do you agree? So that is open set, na? So open ball in R is open set in R. Correct? And open ball in R2 is Yes, open ball in R2 is, you can say open disk, since it is like a disk and it is open. We are not including the boundary, so I'll write open disk. And in R3, yes, you can say open sphere. Here also you can say open circle, but तुमको include करना है boundary, तो you should understand. Open sphere, correct. Okay. So in general, we are not going to say these words. We are going to say just open ball in R, open ball in R2, open ball in R3. And if I ask open ball in R3, then you have to just give this definition. Correct? Now, once I get to know open ball, now I define open set. Correct? In real case, open set was same as open interval, but this is not same in your Rn. So let us define open set first. Do you remember what was the definition? Anyone? Let S subset of Rn be any subset of अभी वो तो लिखा है, so I'll just this subset of Rn, then S is said to be open set if for every E belongs to S there exists an R positive such that BAR that is totally contained in S. So do you understand the definition? When do we say a set is open set? When if you take any point of the set, correct, you should able to draw an open ball. I'll quickly give you an example, something like this. If I'm having this, correct, so this is my set. Suppose I am including the boundary points also, correct. Now my question is, I should find an R such that that open ball should be completely inside that set S. So if I take this over point, so I can have a open ball here. If I take this point, I can have open ball here. But if I take the boundary points, correct? If I take these boundary points, then if I take any radius, any small radius, I'll be having some points which are not of the set, correct. I'll be having some point which are not of the set. So if I include the boundary point, then this is not a open set. But if I exclude the boundary point, correct, if I am not taking this boundary point, yes, if I'm not taking this boundary point, then this is an open set. Because if you take any then I can able to, I'll be having a radius such that I can make a open ball. That open ball should be contained in that. So you just have to give a R, there exists a R. You just have to give that R and that R will help you. Yes, so we had done some examples also. The first example, I think, uh, first was uh, an open ball is an open set. That is quite simple one. An open ball is an open set. Correct? So if I am having a set S, which is set of all x belongs to Rn, and such that satisfying norm of x minus e that is less than say R, correct. So this is my set S. Now I want to prove this set is an open set, and that is quite clear. Say this is A and this is your open ball, and you are strictly less than. So if you take any point inside, I can have a open ball, correct, because my radius is definitely less than 1. So this is clearly an open set. You don't have to prove anything. You just have to choose the same R And I already told you, if you want to prove two sets are equal or subset, what is the step? What is the step? If you want to prove A is subset of B, A and B are the set. If you want to prove A is subset of B, how will you prove that? Yes. If you want to prove A is subset of B, how will you prove that? Since they are sets. Hello. You should write for all x in A, this x is in B also. Something like that. If you take any element of A, that element will be in B. Correct? So this is the definition of A is subset of B. Okay, let us take one more example. Maybe we had done so many examples of the open set, I don't remember. Yeah. Let us take this set. Suppose S is equal to 0, 1 cross 0, 1. What do you mean by this? That means it is having on the first this axis, x-axis, it is having this bond. So since this is subset of R2, so R cross R. So here it is 0, 1. Here it is 0 to 1, and they are not including the boundaries. So I'll put something like this. Okay. Now what is my question? If I take any point here, can I have an open ball? Think about it. If I'm having any point here, can I have an open ball? I just have to make sure that radius should not cross this line, this line, this line, this line. Do you agree? I just have to make sure this thing. So that R must be minimum of all these four things. Do you agree? This point may be somewhere here also. So the my question was to give me a R. So can you give me that R here? So this point, say I'm saying this point is x naught y naught. So what you have to make sure, you have to choose. Let me start. Let x naught y naught belongs to S. Correct. Be any arbitrary point in S. So what I have to choose? I have to choose R. Let R, which is minimum of whom? Minimum of this distance. What is this? 1 minus x. This distance is, this is 1, this is x naught. So 1 minus x naught, and this distance is x naught. This distance is y naught. This distance is total. This distance total 1 minus y naught. Do you agree? If I choose this guy as R, then if you take any point in this set, you have to prove B of x naught y naught comma R that is contained in S to prove. This is what next step is. First step is to choose R. That R you can choose if you know that thing is graphically, if you know, then it is quite clear to understand. But later on you will see graphically भी जरूरत नहीं पड़ेगा तुमको. You'll be able to do by looking at the point. If you want to have here, so यहाँ पे क्या आना चाहिए, maximum distance 1 minus x naught से कम होना चाहिए x naught, something like that. So now this is the question. You want to prove this set is contained in this. How will you prove? Well, you start with, as I told you, if you want to prove A is subset of B, then how you have to go ahead? Yes, you'll be taking a point here, and you'll be proving that point is here in the set S. Correct? So let me start. Suppose, should I start? Let x comma y belongs to this b of x naught y naught r, and you already know how does this b of x naught y naught rd is defined. If x comma y belongs to this, that means what? It is having norm of that is less than norm of x comma y minus x naught y naught, that is less than r. And if you solve this, this is a equation of circle, that is square root of x minus x naught the whole square plus y minus y naught the whole square, that is less than r. Correct? Yes. So this is what you are having. What do you want to prove? You want to prove this x and y belongs to this s. That means what? You have to prove your small x is lying between 0 to 1 and small y that is also lying between 0 to 1. This is what you have to prove. That means after some time, if you prove this, that is x is lying between 0 to 1 and y is also lying between 0 to 1, then we are done. This implies that your x comma y uh, belongs to s. Do you agree? So after this you have to go here. That means you have to first break x alone and y alone. Correct? So how can you do that? Can I do this thing? That is mod of x minus x naught, that is less than, or I will write like this. This is equal to square root of mm, x minus x naught the whole square, and that is less than equal to whole thing. Can I do that? Think about it. Since I am adding something, so that will be definitely greater than only and greater than equal to, and that is less than r. So can I say here that is x minus x naught, that is less than r? Yes. Correct. Similarly, you can do y minus y naught, that is also less than equal to this, and that is less than r. Do you agree? Yeah. Now, now again you want to have bound for x, so you have to break this thing again. That is x minus x naught, mod of x minus x naught, that is less than r. That means what? Yes, x naught minus r, that is less than x, and that is less than x naught plus r. Yes. What next? What should I do? But what is my r? You already aware with. What is your r? R is minimum, no? Minimum of, so r, I can write it as r is less than equal to 1 minus x naught, and r is also less than equal to x naught. So you see how I'm going to use both the thing here. So I just want to have the upper bound, that is x minus x naught को break करना है. So see, if I take this x naught this side, that means what? X naught plus r, that is less than equal to 1. Correct? And if I take this x naught that side, sorry, this r that side, that means what? X naught minus r, that is positive. Positive greater than equal to 1. Do you agree? I'm just solving this thing. Correct? So do I have the lower bound and upper bound for x? Do I have lower bound and upper bound for x? You see, if I write all together, that means x minus x naught. Do you see x minus r? What is 0 is less than equal to x naught minus r, and that is less than x, and that is less than x naught plus r, and that is less than equal to 1. So can I say something? 0 is less than x and less than 1. Can I say this? Think about it. Because x के साथ तो open interval है, and here lower bound is 0 and upper bound is 1. And similarly you have to write for y naught. Do you understand this part? Let us go back again. I am having x naught minus r here, and I am having x naught plus r. So I want bound for this x naught minus r is lower bound, is upper bound. So what I did, but since r was minimum of this, so r is less than equal to 1 minus x naught, and r is less than equal to x naught. So if I take x naught this side, this will be x naught plus r, that is less than 1. That means this guy, this is less than 1, less than equal to 1, and this is greater than equal to 0. So 0 is this, and I'm having this. Similarly prove this part. So I'm having both the thing. Correct. So it was we are able to prove this because we have choose our r this was my r. So main thing of proving a set is open to decide what r you should choose. Correct. If you are able to choose the r properly, then you'll be do you'll be able to do that. Okay. Yeah, we'll be doing some more problem later on, but let us define a new thing, that is neighborhood. Neighborhood of a point in Rn. How does a neighborhood define? Anybody? Let us start. Let P belongs to Rn be any point in Rn. A set S is said to be a neighborhood of P if there exist a open subset of S containing P. That's it. Containing P. That is, if there exists open set U such that P is in U and that U is contained in S. That means S को अगर neighborhood बोल रहे, I can able to find a open set inside that around P. Correct. Let me give an example. This is a set. If I say this point, if I say S is a neighborhood of this point, then what should I do? I should able to find a open set here. So you this point के around एक open set draw करना है. Now remember one thing, this open set need not be open ball, it may be anything. This is also an open set for me, correct, excluding the boundary definitely, and this is also an open set, correct. So this need not be always a open ball, since I have already defined what is an open set, correct. If you remember what is open set, a set is open if around every point in that interval I can able to form an open ball. And what is neighborhood of a point? If around that point I can form a open set. So try to understand the difference between them. Yes. Okay, so this is neighborhood. So closed set तो हम लोगों ने पहले ही define किया था. And if I say a set which is something like this, set of all x comma y such that 1 is less than x plus y and that is less than equal to 2. So this is also a closed set. But if I am having this 1 is less than x plus y and that is less than equal to 2, so this is neither open nor closed. This is closed. This is neither open nor closed. Correct? Sorry, this is one. And you can easily prove that. Okay? So, yeah. So, we'll stop now. In the next lecture, we'll define sequences in Rn.